Hey everyone, we're going to do the practice problems for Unit 5, Lesson 1 in Desmos, or Practice 7.5.1, it probably says in your thing. The first thing we're supposed to do is this warm up. We're going to use greater than, less than, or equal to symbols to relate the two numbers in each pair, the one on the left and the one on the right. So I can get, in case you're not sure, you should be able to get those on your keyboard. Now there's the less than and greater than symbols are on like lower keys down by the M and N on your keyboard, and the equal sign is higher up near your backspace or delete key. And remember, a number is greater than another number if it sits further to the right on the number line, and a number is less than another number if it sits more to the left on the number line. Simple as that. So if you're not sure which number is bigger or smaller, just visualize a number line or look at a number line if you have one available, and whichever one's further to the right is greater, whichever one's further to the left is less than. And remember, your alligator mouth when you're making a greater than or less than symbol always wants to eat the bigger number. So 3 is greater than -3, so I'm going to make a greater than symbol that's trying to eat that 3. 24 is greater than 12, so alligator wants to eat that 24. So -12 is greater than -24 because -24 will be further to the left on the number line. And 7.2 is greater than 7. Oh, I got more. -7 is greater than -7.2 because -7.2 would just be slightly more to the left on the number line. All right, problem number 1. One Monday in December, it was -8 degrees in Harbin, China, and -2 degrees in Beijing, China. Which city was colder on that day? Well, -8 degrees is a lower temperature or colder than -2. So I'm going to select Harbin. And so for explain your thinking, that's probably about what I would put, is that -8 is a smaller number than -2, and therefore it represents a colder temperature. Okay, so same setup, -8 degrees in Harbin, -2 degrees in Beijing. And on the same day, it was about 7 degrees warmer in Shanghai than it was in Beijing. So what was the temperature in Shanghai? So what we're being asked to do here is add 7. So 7 degrees warmer than Shanghai. Okay, warmer in Shanghai than it was in Beijing. So Beijing, that's our -2. All right, so -2, and then 7 degrees warmer, that's plus +7. Well, if you're not sure how to do this yet, we'll come up with some different strategies and we'll get good at it over time. But one way you could do it is just look at a number line. Let's say this is -2, this is -1, this will be, oops, I don't know why I wrote -0, but it can be -0, whatever. We can have -0, that's okay. 1, 2, 3, 4, 5. And now I'm just counting. So if I start at -1 and I count 1, always move 1 before you count 1. A big mistake some students make is they say 1 before they actually go to the next number. 2, 3, 4, 5, 6, 7. Looks like I got to +5. We call this bump counting because we made little bumps. Or I think some people call it jump counting. So looks like the answer to me is going to be 5 though. Okay, and so still the same setup here. All the same degrees in Harbin and Beijing. It's 7 degrees warmer in Shanghai than it was in Beijing, which is the 5. We already figured that out in the last question. Now it wants to know how many degrees warmer was it in Shanghai than in Harbin. So we already know that in Shanghai, it's +5 degrees, right? If we continue this number line over to the left so that we can get the temperature in Harbin on here, which is -8. So there's -3, -4, -5, -6, -7, and -8. Now we can just continue our bump counting all the way from 5 to -8, or from -5 to 8. It doesn't really matter which, and figure out this temperature. So we knew that this was 7, right? So from 5, 1, 2, 3, 4, 5, 6, 7. This one I just drew as the 8th. 9, 10, 11, 12, 13. So there's 13 spaces between -8 and +5. So that would mean that it's 13 degrees warmer in Shanghai. Another way you could have done the same question is by finding the difference between the two numbers. So you could have done 5 minus -8 to figure out how many spaces are between. And subtracting a negative is the same as adding a positive. So really what you're doing is 5 plus 8, which equals 13. You could also do it the other way. You could do -8 minus 5. I'm just taking these numbers here and reversing them to show you that it works both ways. But when you do it this way, -8 minus 5, remember -5 is the same as plus -5, and you get -13. But it's not -13 degrees warmer. And so this is where our friend absolute value comes into play. If we'd have put absolute value bars around this operation before we started, which is what we're supposed to do in this case, but I didn't do it on purpose, then our answer would be the absolute value of -13, which is 13. Either way, we want +13 to be our answer because it's 13 degrees warmer. Okay, and it looks like we still got some of the same setup here. It's still -8 degrees in Harbin. It's still -2 degrees in Beijing. And it says the next day in Beijing, it's 5 degrees colder than it was the day before. So remember, Beijing was the -2. Let me get a new color on here. Let's go with some red. So the first day, the Beijing was -2, and now they want it to be 5 degrees colder. So let's go 5 bump spaces to the left. 1, 2, 3, 4, 5. We get -7. Another way we could have got this same answer is by doing -2 minus 5. But subtracting 5 is the same as adding -5. And so if I've got 2 negatives and 5 negatives, that's going to make 7 negatives. Either way, we want our answer to be -7. All right, let's get some of this stuff off the screen from previous questions. I'm going to keep my number line though. The number line is useful. Let's get rid of all this, all this, all this, all this, and this stuff over here. Okay, it says on Tuesday in Harbin, the temperature started at -6 degrees, but then reached a high of 3 positive degrees Celsius. So it's like getting warmer throughout the day. How much did the temperature rise throughout the day? Okay, let me get a new color. I'm going to go with some green. And I'm going to start my counting on -6, because that's where it says the temperature started at the beginning of the day. And I'm going to count until I get to +3 and see how many bumps and therefore how many degrees we went up. So always count one before you move one. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So look, it looks like it's 9 spaces or 9 degrees to go from -6 to +3. But we also could have used that same strategy from the previous question, where we just subtract the numbers to find the difference between them. But we use absolute value to make sure we get the positive result, because we're looking at like a rise here, which should be positive. There's actually a name for this. It's called the distance formula. This thing that I'm doing here is called the distance formula for a number line. You'll learn a different distance formula in 8th grade that has to do with distance on a Cartesian plane, and it's a little bit more complicated than this one. But the distance formula here is just take the absolute value of whatever two numbers you're trying to find the distance between, subtract it. And it doesn't matter what order you do. You could do -6 minus 3, or you could do 3 minus -6. One of these gets you -9 and the other one gets you +9. But in the end, after you take the absolute value, they both just come out to +9. Okay, so how is changing temperature similar to adding and removing floats on a submarine? Well, I would say that adding floats and removing anchors makes the submarine go up like a rising temperature. Removing floats and adding anchors makes the, oops, I'm just not realizing I got this typo up here. Makes, I did the same typo here, it's weird. Makes the submarine go down like a dropping or reducing temperature. Both of them are like on vertical number lines, right? Like in math, we tend to draw these horizontal number lines. Well, this one isn't really horizontal, it's like kind of diagonal, right? But one thing that's also similar about the submarines and temperatures is the submarine's going up and down vertically, and temperature is also usually recorded on a vertical number line, right? Thermometers are usually like up and down. That's another thing you can put in here if you wanted to. All right, let's finally clear all these drawings. It says a shade of green paint is made by mixing 2 cups of yellow with 3.5 cups of blue. Oh, we're doing a little bit of review of some proportionality stuff here. How many cups of yellow and blue paint will make the same shade of green, but a smaller amount? Okay, well, how about we just cut everything in half? So what if we used half the amount of green paint, or sorry, half the amount of yellow? All right, I got 2 cups of yellow here. Yes. And so I'm going to put a 1 here for yellow instead. And then for blue, it was 3.5. And so I need half of 3.5. I could do that in my head, but remember, you have this tool here in case you can't do it in your head. Oh, apparently they want you to do this one without a calculator. Well, if you can figure out half of 3.5, that's great, do it. If you can't, use a Google tab or use your phone or whatever. In the end, it should be 1.75, I believe. Okay, and so now they want us to do the same thing, but this time a larger amount. This is actually easier, in my opinion, because we can just double everything. If we want to take the yellow that was originally 2 cups and double it, let's make it 4. Oops, that was supposed to be yellow. And then if we want to double the 3.5, that's 7. All right, and now it says a shade of green paint is the same prompt, 2 cups of yellow, 3.5 cups of blue. Will a mixture that is 3 cups of yellow and 4.5 cups of blue be more blue, more yellow, or the same shade of green? Okay, well, let's look at the ratios. So we've got, I'm gonna compare yellow to yellow and blue to blue to see like which one, like how they're changing. So yellow is going from 2 to 3. I see here it says the original has 2 cups of yellow, but the new mixture has 3 cups of yellow. So I'm looking at like old versus new here. And then with the blue, it originally had 3.5 and it's going to 4.5. So 3.5 to 4.5. Okay, well, with the blue, let me just get a different color here. Sorry, with the red, we're going from 2 to 3. I'm lagging out a little bit here. That's times 1.5. If you take 2 and multiply it by 1.5, you get 3. So if they're the same color, then the blue should also be multiplied by 1.5. If we have 1.5 times as much blue, then all the ratios should be equivalent and we'll wind up with that same color of green. But 3 times 1.5, if you were to go and do that in a calculator, or if you can do it in your head, I think you would find that that's more than 4.5. This is less than a 1.5 ratio. This is, oh, I should be able to do this one in my head. We're adding 1 to 3.5. All right, let's go do the division. Let's go do our y divided by x in a separate tab somewhere, because they don't want to give us the calculator here. Well, actually, you know what? I don't actually need to know exactly what the ratio is here. I can tell you right now that it's not the same, because 3.5 times 1.5 is not 4.5. It'd be something bigger than 4.5. So whatever this ratio is here, even though I'm not going to do it in my head right now and I'm not going to go look at what it is, I know that it's something less than 1.5. It's about 1.3 if I had to guess. And so if the blue is being increased by a smaller like ratio or a smaller constant of proportionality, if you want to think about it that way, even though it's not really a constant of proportionality, then that means we didn't increase the blue as much as we increased the yellow. And so I would say that that means this shade of paint is going to be more yellow. All right, and I'll let you write your own explanation there. Oh. All right, I didn't say this in my class, I probably forgot to, but the explores, remember, are like semi-optional. I want you to at least try them, submit something in them so I can see that you like at least tried it. But if you don't get it or can't figure it out, that's okay. That's true for this screen and the next one. Use the digits 1, 2, 3, 4, 5, 6, 7, 8, 9 in order to create 100. You can add, subtraction, and join as many digits as you can. And so here's an example they did. 1 plus 2 plus 34 minus 5 plus 67 minus 8 plus 9 equals 100. All right, and then what's the other explore? Try going backwards. Try using 9, 8, 7, 6, 5. Okay. Yeah, I'm not going to do these for you. I'm going to encourage you to like at least think about them for a little while, see if you can figure them out. But if you try them for more than like 5 or 10 minutes and you're stumped, you can't get it, then type whatever you can come up with that gets you at least to the closest to 100 in both these boxes, so I can at least see you try. All right.